Any young? Well, that's the way we say hello in South Korea. Hello, children. How are you people doing? I'm Saurabh Kumar Dutt, and I'm here to teach you people a little bit about algebraic expansions. Here, we are not going to learn about how to expand your chest or probably something else, but it is going to be expansion of algebraic expressions. I will be telling you when is it that you cannot expand an algebraic expression. Further, we will be discussing some basic, some complicated formulae which are associated with this chapter. Then I'll be leaving you people with a sum for a little while, which I'll be discussing in detail after that time given to you people. Then I will also be giving you people a second explanation so that if there are certain lapses which are left, you are now clear with everything. Then there will also be a question there in the description, which after you try out the sum all on your own, you should do and send it to me in my email ID so that I can understand that you understood this all. Now children, all of this and much more is to happen in this lecture, as now I'll be telling you people the story as to what happened to me when I took my students to South Korea to study algebraic expansions. So we started off and we thought that where is it which can be most suitable to go and study algebraic expansions. One of my students said South Korea. I said that okay, let's go. So when we reached there, we got a guide, and the guide told us, where do you want to go? I said that take me to such a place which is natural, serene and most beautiful, which cannot be seen in any other part of the world. He took me to this place. Isn't this place fascinating? It is. This is Nami Seong Island, Chuncheon, Gangwon Province, South Korea. This is an island which is in the shape of half moon and is not a normal island in a sea, but it is a river island when the river Bhukan inundated the land which was around it. This is a place where you will find divine serenity and such colors of nature which will bring magnificence in your brain, and it will be there with you till the end of your life, and you will feel that awesome color of nature. Now children, after I have discussed this a little with you people, there's much of culture of South Korea. There is much of jokes which happened there in South Korea. Also the different dishes that we had, which was really mouth-watering of South Korea, which I'm going to discuss. But let's quickly dive in to the basic concepts and understand a few things. Look, if say we talk about an algebraic expression which say is something like ax cube plus dy cube plus z, right? And if say we want to expand this, so will you be able to expand this? Tell me. So this is a case where expansion is not possible, right? Because this is already expanded, right? So an algebraic expression can be expanded if it is something like this, like a upon b plus x upon y whole raised to the power 3. So since you can get to the power 3 of this binomial, so as such you can expand this. So such an expression which can be expanded is actually an expression which is raised to some power, or probably is multiplied with some other algebraic expression, and they are the ones which can be expanded. So these are the expressions in which expansion is actually possible. So that's why I have put up a tick here. Now children, after this, let me quickly give you an idea about what are the normal formulae that we have in expansions. For that matter, if say now we talk about the first formula, we can talk about the basic formula, which I'm sure is laughable stuff to you people, as that's the most easy one and you've learned it probably in class 8, I'm sure, or probably at a junior class, but since then you've been using it for long, as it is pretty important, right? So what is it? Can Abhi tell me? Very good. So the first formula that we're going to talk about is, we will be talking about a plus b whole square. And this, children, is pretty simple. This is a square plus 2ab plus b square, right? So what is the next formula? The next formula is when you talk about a minus b whole square. So here you write this as a square minus 2ab, right, plus b square. Then, children, there are other formulae that we can write. We'll just write a few, and we'll not be writing all, and we'll just be writing the ones that we will require in the sum to come, right? So that becomes pretty simple with you people. So now, children, another formula. If, say, we talk about a plus b whole raised to the power 3, we have it to be a cube plus b cube plus 3a square b plus 3ab square, right? Similarly, children, there can be another formula. If you talk about a cube plus b cube, remember, this is very different from the above formula. The above formula is a plus b whole cube. That means there is a binomial, and then there is a cube of that binomial. However, here in the monomial itself, there's a cube. In the monomial, there is a cube, and both of these monomials, they are getting added together to become a binomial. So this is entirely different. However, this can be further simplified and factorized. So did I say something in which there is a special meaning which is hidden for this exercise or this chapter? I will be further writing the explanation, the expansion of this as to be a factorized expression, and you tell me what the answer to my question is. Anybody who is able to answer, I will award you with a 5-star. Yeah, the one which is eatable, not the one which is given on your cheek. Okay. So a cube plus b cube is given by a plus b times of a square plus b square minus ab. Do remember this. Now, can you tell me? I told you there is something that we can get from this expression. What is it? Well, I'll tell you. Look, if we talk about expansions, do remember that expansions is what? Expansion is when you have the power of an algebraic expression to be something, then it can obviously be further expanded, or if it is the product of some algebraic expressions, then it can be multiplied to give you another algebraic expression, right? However, if, say, now we talk about the other, then it is going to be what? One is expansion, remember, like I told you, and the one which is opposite to it, or the one which is antagonistic to it, is factorization. There was nobody here in this class who had this answer, right? But I'll tell you how. Now just look up. If we have something like, say, x plus 4 raised to the power 2, right? You say that this is factorized because this is actually the product of two factors, both being binomials, that is x plus 4, which is multiplied with x plus 4. So finally, whenever we talk about factorization, what we actually want is we want to have an algebraic expression which is a monomial. Always remember this, right? And when you do not want that the algebraic expression be a monomial, that is when you tend to expand, right? So here, if we try and expand this, then this expansion can further be written as x square plus 8x plus 16, right? That is a square plus 2ab plus b square. Now, children, here you get to see that this is no more a single term. That means what are you trying to do here is you're trying to do, when you're trying to do an expansion, is you're trying to convert a monomial to one which is no more a monomial. It can become a binomial, it can become a trinomial, or it can even be a polynomial. So when you break it off from being a monomial, right? That is why I'm crossing it off. That means you're breaking it off from being a monomial and you rather convert it to something which is different, that is, which is either a binomial, right, or which is a trinomial, or probably which is a polynomial, right? Then we say that we are actually trying to expand. So do remember this very important thing which I said was that when you factorize, then what you do is you have an algebraic expression which has different terms, and when you have factorized, then you just get one term. That means your task is to find out a monomial. But if you have an algebraic expression and then if you reverse this and if you try removing it as it no more remains to be a monomial, then that process will be said to be an expansion. I'll give you an example. Like if we have x plus 4 whole square here, this actually is a monomial because it is a product of two binomials. So finally, if it's a product, you will say that it is a monomial, right? But if you expand this, then this will no more remain to be a monomial, and that is actually what expansion is trying to do. Do remember this. This is a very important fact, a very basic fact that you should know, that what is the opposite of what in a mathematical operation and what is it that it actually does. Now children, after we've discussed this, we have also looked at a few formulae, so I will quickly discuss those formulae again, and if there are more which are required, so in times to come I will tell you that. So here children, we talked about that when we talk about a plus b whole square, then that's actually equal to a square plus 2ab plus b square. A minus b whole square is a square minus 2ab plus b square. If we talk about a plus b whole cube, then that is a cube plus b cube plus 3a square b plus 3ab square. If we talk about a cube plus b cube, then that becomes equal to a plus b times of a square plus b square minus ab. Now we can also write those formulae which are very close to these formulae but just a little different. For that matter, if suppose we now talk about a minus b whole cube, as these are closely related, so that's why I'll write it very close to it. So this is going to become equal to a cube, right? And then we will have minus b cube, then we will have minus 3a square b plus 3ab square, right? Now to remember this a little better, there is another way that you can write this, and that I'll tell you. That is, you can write this as a cube minus b cube, right, minus 3ab times of a minus b. Right? So this is a way that you can learn it, and it becomes more simple as you get to see that here also you have a minus sign between a and b, then here between aq and bq you have a minus sign, and then for there's another minus sign, and then again between a and b there's a minus sign. So this is a way by means of which you can learn it more easily, and when you expand this, then obviously what will happen is you will actually get to this. Now children, another formula which is pretty close by to a formula that we just discussed, that is, if you talk about a cube minus b cube, now children, this becomes equal to a minus b times of a square plus b square plus ab, right? So here, as you see on the left hand side, we have a binomial, that means an algebraic expression which has two terms. However, if you look at the expression which is on the right hand side, it's been factorized and it has been brought to a monomial, right? Now children, the product of these is what comes on the left hand side. So these are a few basic formulae, and they are pretty important. More when they come, I will discuss it with you. Moreover, if you like to have a longer, a bigger, a more detailed lecture series, then you can write to me in my email ID. Moreover, there is a form. Do fill the form, then I'll get back to you and I will provide you more so that your inquisitiveness is properly answered, right? Moreover, if you have any doubts in mathematics, do write me a email. I'm sure to get back to you, right, and help you out. Okay, so children, now after we've learned all of these concepts, let's now get to a sum. So like I told you, I'm going to give you people a little time to try out the sum, and after that I'll be discussing the sum with you people. So at the moment, with all the children who are online, it is just 10 seconds that I can give you. I'm sorry, but those children who are offline can obviously do what they can pause the lecture for a longer duration of time, give it a bigger try, and then get to the solution which I'll discuss. Okay, so let's start. Now before I start, I like to quickly ask you people, are you sitting at a secluded place? That means there shouldn't be any person who is close by to you to disturb you. You shouldn't be having a mobile, a computer which is playing some game, or probably some music system, or a television set, or anything else. Make sure that you're sitting alone and you're studying this lecture just like your self-study. Sit on a table and chair that provides you the maximum amount of concentration during studies. If you're sitting on a bed, then gradually the pose changes. As your back starts aching, you come to your elbow, then you lengthen your elbow, then you put your head down, and after a little while you are gone up and away, right? So make sure you're seated on a table and chair. There you will find that the study will come out more sincerely, right, Abir? This is what you do. Yeah, I know there are many children who do it this way, and that's why they end up working very less hard, because when you're to study, you're actually doing hard work, and that is the time when your body language should be correct. If your body language is not correct, then you will not be able to get the optimum result that you're thinking. Okay, so now children, the last thing, always remember that be where my pointer is. So if my pointer is pointing here, then you should be here. If my pointer is here, then you should be here. That means your attention shouldn't be a little forward or shouldn't be a little backward. Just be with me, right? Might be you'll find that sometimes my pace is slow. That is because everybody in the class is not the same. Different people have different approaches, different people are coming from different backgrounds, different people are in different levels of their understanding, right? So bear with me and those children, but focus exactly where I am, because that is the thing which will provide you the maximum amount of knowledge that you can derive from this class, right? Moreover, I also give a second explanation. So make sure till the time I give you the second explanation, focus completely the way that I told you, and don't pick up your writing material. Neither a pen, nor a book, nor a copy. Just focus what I'm telling you, and after that immediately do that sum once more, and that will help in the assimilation of all that has been told to you, and you will understand that very nicely. Okay, so try it out. Okay, so before I start this off, like I told you, in between I'll keep telling you people different stories of all the things that happened to us in South Korea. Now the next thing is, now what happened was I met one Mr. Kunshaw, I believe. Yeah, I said any young, as I was taught, right? And then he said to me something, and I asked the guide, what is it that he's telling me? The guide said, he is telling me, have you had rice? Well, I was perplexed. What does he mean by this? Although I have rice, but have rice very little. And how is it that he knows that I eat rice? So then I asked my guide, and my guide said that this is actually how people tend to show their concern, right? In South Korea, when you ask a person, how are you, right? They do answer, but in concern, they ask you back, have you had rice? That means, have you had lunch or breakfast, whatever, because rice production is more there, right? So you can just take it as a joke, but actually this is their tradition, right? Moreover, when we proceed further, I will tell you more jokes, right? And if my jokes are something which are not appealing to you, then you can say, as what happened to me when I did such a sort of a joke. But at the moment, let's quickly focus to what we are studying. Okay, So do remind me that I've got to keep telling you these jokes and these memories, okay? Okay, so now children, let's get back. The first thing that we've been asked here is we have to find out the value of a minus 1 upon a, given that a square minus 3a plus 1 is equal to 0. Right now, when this is equal to 0, the first thing that we've got to do is we have to find out an expression which can get us this expression. So let's give it a try. So now that the thing that we have at hand is a square minus 3a plus 1, one thing which can help us to get the a in the denominator is to divide by a. So let's do what? Let's quickly divide by a. Right, so when we divide the whole equation by a, this is what's going to happen. We will have a square minus 3a plus 1, which will be whole divided by a, and as we are doing it to the equation, so obviously this will happen even to the right hand side. Always remember that whenever we have in the numerator 0 and in the denominator any number b, the value of this fraction is 0. So as such, on the right hand side, we can further write in the next step that it is going to become equal to 0, but left hand side is what we've got to see. So this will become equal to a square, which will be divided by a, minus we will have 3a divided by a, and to that is going to be added 1 upon a, and on the right hand side we will get this to be 0. Now children, how does this happen? I'll tell you. If you talk about some a plus b which was divided by c, then you get it to be a upon c plus b upon c, right? Now that is because when you take an LCM, you'll get back to the same, right? So when you require, you can break up the terms in the numerator to be numerator upon denominator, right? But remember that is only possible if the denominator is a monomial. Okay. Now children, after this what we can do is there are certain common factors which we find can get cancelled from the numerator and from the denominator, like we have this a, right, and then we have this a, right. These are the ones which get cancelled. So now let's write what we are left out with. Now the first term is a, right, and after that now the next term is just minus 3, and then after that we have 1 upon a, and the sum of all of this is equal to 0. So next now children, what we do is, as we require something like a plus 1 upon a or a minus 1 upon a minus 1 upon a, so obviously if we do with a plus 1 upon a for the time being, that's going to help us. So we now have a plus 1 upon a, which can be written to be equal to 3, and children, you can mark this to be equation number 1, right? So in other words, what do we have is we have a plus b, and we require to find out a minus b. So now let me quickly explain to you people a few things. Now if you talk about a minus b, and if you square it, then what is it that you're going to get? You will get a square minus 2ab plus b square. And similarly children, if we now talk about some a plus b whole square, then what are we going to get? We are now going to get a square, right, plus 2ab plus b square. So there are two terms which are common. One is a square and the second is b square, which are common in both of these. Now in one you have minus 2ab and in the other you have plus 2ab. So as such children, here remember that we can now write this as we require now a minus b or a minus 1 upon a. So we can now write a minus b whole square, which can be written to be equal to a plus b whole square, which will have a square plus b square plus 2ab, but we do not require the plus 2ab, we require minus 2ab. As such, here we'll be subtracting minus 4ab, so that minus 2ab gets cancelled with the plus 2ab, and then you are left out with minus 2ab, which will make it a minus b whole square. So this is a relation which you require to remember, right? And as such, I will put this up in a rectangular box in your examination also when you're using such formulae which are a little different, right? And the teacher requires to see it to give you marks. You should put that in a box. Okay, now that we have this formula, so in this case also we will be able to find out what a minus 1 upon a is, and thus we can say that a minus 1 upon a whole square, because now in place of b we have 1 upon a, that will become equal to a plus 1 upon a whole square, and from which is going to be subtracted 4ab. A is A here, however B is 1 upon A. So both of these get cancelled and it just becomes equal to minus 4. Now children, as we have the value of A plus 1 upon A, which is 3 from equation number 1, so we will substitute here. As such, we will now have here 3 square, from which is going to be subtracted 4. So as 3 square is 9, from that if you subtract 4, then you will get 5 here, right? And as such here, 9 minus 4 becomes equal to 5. As such, 5 is then going to become equal to the value of A minus 1 upon A whole square, right? So children, as we have this, and since we require A minus 1 upon A, so obviously by taking the square root of both the sides, we will get the value of A minus 1 upon A to be plus minus root 5. Okay, right. So now children, all of this that I told you, I will quickly explain to you people, and after that move along to do the second part. Now children, in the question we've been given here that we have A square minus 3A plus 1 is equal to 0. At this time, Abir, you don't have to pick up your pen, put your pen down, sit straight with your spine straight. No book copy at this time, because if you start working at this time, trying out something which is probably good, but you will lose then the good that I'm trying to give you, right? Okay, so now children, here next what we do is we now talk about A square minus 3A plus 1, which is the given equation, and from it we just try and bring something like this, or probably something which is similar to this. So we require 1 upon A. That means in the denominator we require A. So as such, what we do is we now divide the above equation by A. In doing so, what we'll get is the numerator, which now has a denominator to be A on the right hand side. Also it becomes equal to 0 upon A. Now this is where you've got to remember that if you have a fraction which in the numerator has 0 and in the denominator has any number from the set of real numbers, then what will happen is this will come to be 0, right? However, 0 upon 0 is undefined, so don't try that. Now children, as here in the numerator you have a trinomial, so you can break this up as the first term divided by the denominator minus second term divided by the denominator, and so on. As if you have A plus B upon C, you can write that as A upon C plus B upon C. So when you do it children, we get to see that one part of A will get cancelled from the numerator and from the denominator of the first term, and in the second term again that will happen, which will give you minus 3. So we have A minus 3 here, and then plus 1 upon A. So as such, we get to A plus 1 upon A, which can be written to be equal to 3, which is pretty close by A minus 1 upon A as is required in the question. So next now children, what we do is we will now talk about here getting to A minus 1 upon A from A plus 1 upon A. So we quickly look up this concept. A minus B whole square is equal to A square minus 2AB plus B square, and then we also look up A plus B whole square, which is A square plus 2AB plus B square. Now children, next what we do is if we want to write this from this, we know that both of these have two common terms, that is A square B square, right? So as such, the only thing which has to be changed is the 2AB term, which is causing a problem. So as such, we write A minus B whole square will be equal to A plus B whole square, as it will give you A square plus B square, but here it will give you plus 2AB, and as you require minus 2AB, so if you write here minus 4AB, the minus 2AB will get cancelled with the plus 2AB, and thus minus 2AB will be left out, which will give you A minus B whole square. So this is a relation that you can use here. So here in place of B, we will now be substituting 1 upon A. So you have A minus 1 upon A whole square, which will become equal to A plus 1 upon A whole square, that is A plus B whole square, minus 4 times of A times of B is 1 upon A. So both of these get cancelled and it just becomes equal to 4. Right now children, as we know that A plus 1 upon A has been given to us to be 3. Now we've got to square it, so that becomes 9, and from that when you subtract 4, it will become equal to 5. So A minus 1 upon A whole square is 5. As such, A minus 1 upon A can be written to be plus minus root 5, right? So this is the answer to the first question. Now children, after you have this, you have to come to the second part, where we've got to find out A cube minus 1 upon A cube. Remember, I told you a formula for this, and that is what we are going to use here. So for the second part children, first I'll be telling you people about the formula. That is, if you talk about A cube minus B cube, then that is Abir equal to how much? Why am I asking you questions again and again? Because today you are there in the spotlight. Yeah, tell me. Okay, very correct. That is a minus b times of a square plus b square plus ab. But you were able to tell this when you were guided by Heather. Right? He is just sitting behind you and he is quietly telling you what you should tell. Is this what's going to happen in everything that you do in life? Everywhere you will take Heather along? No. So better learn the formula. The best time to learn the formula is when the teacher has told you. Immediately just revise it in your brain. You'll be able to remember it for a longer duration of time. Okay, children, now after this, we now get to what we actually require in this sum. In this sum, remember, we require a cube minus 1 upon a cube. So it is similar to this, and this is what we are going to do. That is, we will now try writing this as the formula that we have at hand. So a cube minus 1 upon a cube can then be written as a minus 1 upon a, which is just like a minus b, times of a square, which is a square, plus b square, which will become plus 1 upon a square, right, and minus ab, which will become equal to a, which will be multiplied with 1 upon a. Now here, children, there will be something which is very nice that will happen to you. That is, both of these things will get cancelled, and as far the simplification is concerned, this will just give you 1, right? As such, now you will have a minus 1 upon a value that we've already found out, and that is plus minus root 5. So let's take it to be root 5, right? One of the values. Now after that, children, now we talk about the next. Here, as you require a square plus 1 upon a square, let's quickly get to the value of a square plus 1 upon a square. Excuse me. Now if you talk about a plus b whole square, you know that that becomes equal to a square plus b square plus 2ab, right? So to be able to get to a square plus b square, that actually is equal to a plus b whole square, from which 2ab is subtracted, right? So as such, here also we're going to do the same. We know that a plus b whole square is something that we've been given, and if I remember correctly, you were given that to be 3 from equation number 1. So here what you will do is you will substitute that value to be 3. You will square it, that is, it will become 9 in the next step, minus 2 times of a is obviously a here, but if you talk about the value of b, it is 1 upon a. So here again what will happen is you will get to see that a will get cancelled to your satisfaction, and as such you will get this to be 9, from which 2 is to be subtracted. That is, this is going to become equal to 7. So a square plus b square, children, can be substituted to be 7 here. So as such, now you will have root 5 times of 7, right, from which 1 more is to be subtracted. As such, if you talk about this value, it will come to 6 root 5, as 7 minus 1 is 6, and that, children, is going to become your final answer. So I will just quickly discuss this once more. In the question, you've been given a cube minus b cube, whose value is to be found out given that a minus 1 upon a, or rather a plus 1 upon a, is how much? It is 3, right, which we've been able to find out from this equation. Okay, so after we have this, children, now we quickly are reminded of a minus b whole square, which gives us a square minus 2ab plus b square, and from there then we find out the value of a minus b. Now we also have the value of a minus b with us, which is root 5. Now further thus, we just have to calculate a cube minus b cube using the formula that I taught you just now. That is, a cube minus b cube will become equal to a minus b times of a square plus b square plus ab. Do remember that in the cubic, if there is a minus sign in between, then in the linear there'll be a minus sign in between. And when you talk about the quadratic expression, in place of 2ab, it'll be just ab. Normally when you talk about a plus b whole square, it's a square plus b square plus 2ab. Just think that here in place of 2, it'll be just 1ab. So this is how you can remember this by this mnemonic. And after that, now we apply this formula, that is a cube minus b cube becomes equal to a minus b times of a square plus b square plus ab. Now here further what you do is, if you talk about the value of a minus 1 upon a, we've already found it out to be root 5. So we keep root 5 here, and then further it is to be multiplied to a square plus 1 upon a square minus 1, as b is 1 upon a, so a will get cancelled from the numerator and from the denominator. Now to get to a square plus 1 upon a square, what have we done here is we know that a plus b whole square is equal to a square plus b square plus 2ab, right? So we require a square plus b square. As such, if we transpose this 2ab to the other side, right, we will then be able to get the value of a square plus b square. And this is what we've done. Since we know that a plus b has been given to us, that is a plus 1 upon a has been given to us to be 3, so we write 3 here and then we square it, and from that then we subtract 2 times of a times of 1 upon a, as b is 1 upon a. So cancelling both these off, now we have 9 minus 2, which becomes equal to 7. So as such, here 7 is going to become what is the value of a square plus b square. And children, this value then is to be substituted here in place of a square plus b square, right? And from that then further 1 also is to be subtracted, and both of these a's will get cancelled, and that will then give you 6. And a minus 1 upon a is already root 5. So as such, 6 times of root 5 will become your final answer, right? So here children, what you can do is you can consider this a square plus 1 upon a square whose value was found out to be, say, some equation. I think we've already gone up to equation number 2, equation number 1, right? And we can consider this to be equation number 2, right? And now children, this thing that you found out you can consider to be equation number 3, right? And here you can state from equation number 3 that you have substituted the value of a square plus b square, right? So here you can just make a brace bracket, and then you can say you found out the value of this from the third equation, right, which is underneath below for better. Linking, you can mark it with 2 asterisks, and here too you can mark it with 2 asterisks so that the teacher can easily locate where you've done what. So is everything that I told you people about getting to this answer perfectly clear? Sure? Yeah, I'm sure you people are waiting for another joke. I'll tell you. Now, do you know that South Korea is known for its funny museums? I'm sure you'll be amazed to hear that there is a Poo-Poo Land museum in South Korea, which is all about poop. Well, I'm feeling ashamed, but the people who made it didn't feel that way, right? Now, if you make a silly joke, like suppose what happened was I made a silly joke, right, to a South Korean child. Now, when we were there on the visit, now the South Korean child said something to the guide. I asked him, what did he say? He said that this man is doing a papa joke. I said, then what is that? They mean that whenever there are silly jokes which are made, right, which actually don't make you smile, and which don't even make you smile, they are known as dad jokes, as normally dads do, right? Things which are not in context, probably they were there in their times, as such they are not laughable by the new generation. More, something to learn from. Remember, South Korea was a very poor country few years behind, say something like 20-30 years behind, right? Then what happened was there was a dictatorial rule, right? And the positive thing about that was there was a lot of discipline which made the South Koreans do the things as they should have been done. And because of that discipline, today South Korea is counted among one of the most rich countries. So one thing that we get to learn here is, although discipline is something which you normally want to break, right? But if you are able to fall in discipline, if you are able to follow discipline as is said to you by your teachers, your parents, right, or probably any elders, following it for some period of time, you will find that there will be a momentous change in your progress, in your personality, and in the result that you were expecting. Right? So discipline is something which is mandatory. Another thing which is very special about South Korea that I found out was an amazing fact that when South Korean children reach high school, they are spending 16 hours of their day in the school, primarily studying. right? And if you compare it with yourself, I'm sure you'll be able to understand how much less you're doing. And this hard work actually pays, because South Korea is considered to be one of the places which is best educated in terms of the knowledge that the children have, right? And in terms of the different methodologies which are adopted so that the education come to the children easily, so that the analysis can be better, right? So this is another thing to learn from, that do work with your studies. That is something which can take you as well as the country higher, right? Now, another special thing about South Korea that I got to know is 68% of the South Koreans are graduates. Now, that is an old statistics. I don't know what's happened now, but this is how the South Koreans are. Here we talk about literacy. We just talk about simple things that a person should be knowing, the alphabets, how to write their names, and some simple addition, subtraction, etc. We call it to be literacy. But becoming a graduate is a lot of years of good study. And the amount of study that I told you is really large that the South Koreans are putting up. As such, gradually what's happening is they're academically rising, their knowledge is rising, they will be able to bring in new things, and thus tomorrow they'll be able to rule the world. So this is something that you also should learn. Start bringing this to your practice, that you got to take up higher education, learn more things, and it is only then you as well as the country will rise as a whole. So children, this is all that I have for you people in this lecture. I hope hearing the story, the jokes, the knowledge that I provided you here has been pretty awesome and you understood it. And if it is so, then I expect to provide me motivation, you should subscribe to my channel so that next time when I put such good content, you are able to be content with the understanding as well as with all the humor and something that we get to see here, that is the knowledge as to how you will also rise in your life, a little bit of morals, right? Another thing, children, you will find in the description that there is a question of this type which I expect you people to do. And after you've done it, make sure to post it to me in my email ID so that I can check that you really understood this and you've been able to do the sum. So children, bye for now and we'll meet again. Bye.